27 particles, and here we are ready for another video to hopefully help with the tasks that you've been set for the week beginning the 27th of April. The focus this week is also a biology focus. It's kind of based around Charles Darwin and adaptations and evolution. So I thought I would just, as we did last week, give you a little bit of help for each of the 4 tasks. So here we go with task number 1. So task 1 this week is an investigation. There is not 2 options this week. I want you all to do this investigation this week because I'd love to create a whole year 7 data set for this task. Investigating which is your dominant side for various aspects of your little human body. So handedness, eyes, feet, various things. So you're going to follow the instructions for doing this. So for example, one of them is someone's got to throw something at you, it doesn't matter what it is, and you have to catch it. Which hand do you catch it with? So I can catch my dominant hand, I would write down as my right hand. Then you might ask someone to throw something to you and you're going to kick it. Which foot do you use to kick? So it apparently is also my right. There's another task, you just sit there, Katie. There's another task where you've got to put your hands together to make a triangle. And then you've got to put them a little bit closer, find something through that field of view, as if you're looking through a little microscope, keep one eye closed, and then when you change eyes, which eye just changes the image? Whichever eye changes the image, it's my right eye, it moves, that's my dominant eye. So good luck. What I really want you to do is send me this data by Friday. And I will put all the data together and we'll see what year 7 in terms of percentages of dominance is. Send me the data, good luck. Right, so task 2 is all about Charles Darwin. Now, Charles Darwin was born in England just over 300 years ago, and he was the guy who gave us the first thoughts, really, on evolution, on natural selection, and he talked about having of organisms, living things, having traits, characteristics that would become useful and favourable to them. And then the more useful and favourable those traits and characteristics become, the more they are kept, and less useful things about us, less useful traits or characteristics, we end up not passing on to future generations. And so we select the traits that help us survive. So that was his most famous work, along with other scientists, which you'll read about in the pack that's provided. Also his voyage, his 5-year voyage on HMS Beagle was very, very famous. He went to Australia, he went to the Galapagos Islands, he went to lots of places. You'll read about all of that in the information. Now, one thing just to help us understand this idea of natural selection, there is some examples in the pack that you've got to read. Please do try and answer the questions. But there's another very famous example where we're referring to the Industrial Revolution. So during the times of the Industrial Revolution and following the Industrial Revolution, and you can look up what I'm talking about and when, it was discovered that there was many, many more dark peppered moths around than light peppered moths. And there used to be many more light than dark, or at least an equal balance. But after the Industrial Revolution, there was many more dark peppered moths. And people started to think, why? What's happened? Has the smoke and the smog from all the factories that were built and burning coal, all the fossil fuels, did that make the moths dark? And actually, no. According to people like Charles Darwin, he said that what happens is the light moths that used to go on these lovely trees that were a healthy colour, covered in lichens, a light colour of tree, those light moths used to get some camouflage. But when the Industrial Revolution was occurring, there was lots and lots of smoke, and that actually made the trees covered in a thick smoke. It made them bare, the lichens died, and those light moths were not camouflaged anymore. They were very much open to predators. The dark moths, however, were camouflaged on these trees. And so when they've looked at all of this, and what gets passed on to generations of moths, is that the dark peppered moths ended up surviving longer. and they survived long enough to breed more. And the more babies they had, they were passing on their dark genes for their dark wing colour to their babies. And that ended up being the common trait that was passed on. And so effectively, in this process called natural selection that Charles Darwin talked about, it ended up fading out the lighter species and ending up going to the darker species. Please look it up. Lots of information about the peppered moth. Enjoy learning more about Charles Darwin and try and answer the questions. Good luck. So task 3, as always, is our explanations. This week, I haven't given you 2 options either. I want you to be creative, be imaginative, come up with your own organism. It can be a combination of 2 or 3. But what I want you to explain to me is what adaptations does it have to survive in its habitat? How does it survive? What features, traits does it have that means it can get rid of predators, warn predators, get its own food, keep its body temperature as it should do? So for example, if we have a think about a ladybird, now ladybirds, there's about 5,000 species of ladybirds, believe it or not. They live all over our planet, apart from the poles where it's cold. They don't like being cold. They can't quite handle that in their habitat. They have various adaptations, which means they survive as long as they possibly can to breed. They have a very colourful back, very colourful colour to themselves, either this red colour or you can see yellow ones, and that's to warn predators, to say, get back from me, I'm a dangerous colour. They also have a hard shell, actually, that's just over their wings, and that means that's also protective for them. They also, I don't know if you knew this, they secrete a yellowy, yucky, smelly liquid, which has not got a nice odour, which tells predators, get away, I don't want you anywhere near me. So they have many defences already, but they can't live in cold places. Whereas a penguin, penguins can live in cold places, and that's because they have a layer of fat and blubber just underneath their scale-like feathers, which means they can stay warm. And their scale-like feathers themselves keep them nice and cosy too. So imagine my animal, imagine mine was a penguin crossed with a ladybird. That means my creature, my organism, could live anywhere on the planet because it would have the features, the adaptations to stay warm, but it would also defend itself. So would it have funny little feet? Would it be like a little ladybug walking like a penguin? Would it be bigger? Would it be my size? I don't know. That's what you've got to decide. You could also come up with something like a narwhal and a monkey. So imagine you had features of both of these. That means they could live in a completely different habitat. Okay, there you can go back to your rightful owner. You could also say things like, okay, so what about if a dog could make its own food by photosynthesis? What if a dog had ears or a head that was actually leaves? That would be pretty cool. So you come up with your ideas. I can't wait to see what you come up with. Good luck. Now, task 4 is watching the video. And this video is all about amazing adaptations that plants have to survive. Now, I thought I'd get you thinking about the plants in your gardens. We have wisteria here in our gardens. Many people do in this part of the world. And these plants, I don't know if you know, are quite toxic actually. Not really so much to us unless you're going to try and eat the whole thing. But it's more to animals that are going to come and try and munch on leaves. A little bit of hungry organisms that come along. Those little organisms this is toxic to. Any of the flowers, the leaves, or even these bark covered stems, they can be toxic if little organisms come and try and nibble on them. So that is the wisteria's way of saying, get back, leave me alone, I'm here to survive and I'm here to flourish. So in our garden, as well as wisteria, we also have these palms. Now palm trees also have adaptations, which means they can survive in really windy, wet places, which we know the UK can certainly be, and also in the tropics. And they can survive because they have leaves, these leaves, which are like fans. And they can be blown and hit around, and they won't be damaged because the wind and the rain can move through these fanned leaves really, really, really easily. So the tree doesn't get knocked down, it doesn't get damaged. It's very clever. It also has these very straight, and sometimes palms have very, very tall trunks, and that's to get them away from the ground, right up to where the sunlight and good quality air can be found. Another of their adaptations is they have a really, really large, solid root cluster. And that means that they can stay in the ground when they're being blown around in the wind and rain. They can stay where they need to be staying. So that's lots of others in your video, not wisteria and palms in your video. Other interesting plants in your video. Take some notes, see what you think, and I will see you next week, ready for next week's challenges. Right, so we've got these 3 little munchkins to say goodbye to you this week. They are doing really well. They are trying to walk. They're slightly dazed by the world, aren't you? But you're doing really well. They're trying to wander around and cause havoc. So from me, it's goodbye. And from them, it's goodbye. And they have certainly adapted to survive as little fluff balls in this crazy world. Bye-bye.